welcome to Pre-Calc and Trig. Today we are covering 1.1, modeling and solving equations. Okay, so let's just get started. So basically, first part, we're gonna be answering questions over graphs or answering questions over tables, talking about scenarios and figuring out like basically what does this data represent? And we're gonna model that with equations and graphs and everything like that. So first one, we have, this talks about the minimum hourly wage in different years from 1955 to 2005. They're increasing by 5. And so it talks about what the hourly minimum wage is for each year. And then it talks about the purchasing power. So first A, it says, in what 5-year period did the actual minimum hourly wage increase the most? So basically, from 1955 to 1960, it went from 75 cents to $1. So it increased by 0.25. So we're looking for what gives us the most increase. So if you look from right here to right here, it was plus $1 whole, and that was the most. Okay, and so from 1975 to 1980, it increased the most. And then it says, in what year did the worker earning enjoy the greatest purchasing power? And so we look at our purchasing power, and what was the greatest? Well, if we look, our biggest number is 6.47, which was in 1970. Okay, that's all you gotta do. Just basically look at what it's asking and answer questions. Okay, now let's talk about matching a table to a graph and an equation. So if we have this table, I really wanted to talk about that. This because of this right here. This, anytime you see that in MathXL, or it talks about, like, that's the range of the scale of your X and your Y coordinate points based on your graph. This is in your textbook and this is in MathXL, but this is what I want to talk about really. So if this is your X and your X, and this is your Y and your Y. So basically this is the range or the scale of your X values. So it goes from -30 to +60. So it's saying that this farthest X point is -30, and it goes -20, -10, 0, and then 10, 20, 30, 40, 50, and then this one is 60. Okay, so like this would be 10, 20, this one would be 30. Okay, so the scale from the X's would be from -30 to -60, and then the same thing for our Y's would be -30 to 60. So -30, -10, -20, 0, 1, 10, 20, 30, 40, 50, 60. So it's basically the scale, instead of length by width, it's X's by Y's. Okay, so it's your X values by your Y values. So, and that will help us whenever we're trying to figure out our graphs, because if you look for our X values, it's a constant increase. So it's 10, 14, 18, 22, 26, 30, and then Y's 2, 4, 6, 8, 10, 12. So it's a constant increase between our X's and our Y's. Okay, so as our X's increase, our Y's increase. Not as much, not as quickly, but so we'll talk about that slope in a second. So basically we gotta match this graph. So this is a constant, it's linear. So I can go ahead and eliminate some. If I look at B, that's a quadratic. This does not represent a quadratic, it's not exponential. Okay, and then if we look at A, okay, that would be like a square root function where it's increasing slowly. Well, it's not that. Okay, so let's look at either C or D. Those are both linears. And so I'm going to look at my scale, use my scale to help. Okay, so if at 10, 2, so this coordinate point, 10, 2, so 10 would be here, and 2 would be like right here. If you notice, this graph does not pass through that point. That's like 10, 20. Okay, here, 10, 2 would be like barely right there. And so we know our answer is D. Okay. So if we looked at, that's the X and Y, I didn't mean to erase that. So now let's talk about our algebraic model. And so you can kind of look at, your slopes and your y-intercepts. So basically we can see from our line, it crosses below 0. So it has a negative y-intercept. So I'm gonna kind of look at these. And so I'm gonna go ahead and eliminate A, and I'm gonna eliminate C because those have positive y-intercepts. Another thing that we can look at is slope. So if we pick 2 points, I'm going to pick 10, or 2, 10, or 10, 2, and 14, 4, sorry. And if we know, remember from our prerequisites, so we have y2 minus y1 over x2 minus x1. So our y's, the difference in y's, I'm going to say 4 minus 2. And the difference in x's, I'm going to say 14 minus 10. So I just said 4 minus 2, 14 minus 10. Okay, that would be 2 over 4, which is 1/2. Okay, so if you look, this is a slope of a 1. This is a slope of 1 over 2 and a negative 6 over 2. So your answer would be D, because that is the same thing as y over 1 over 2x minus 3. Okay, so D would be your answer. And so here we have another fitting a curve by data. So we are basically trying to match this data with an algebraic model. And so this talks about percentages of females in the prison population. Okay, so there was a previous example, I skipped it, and we're gonna go to this one to talk about the how to make an equation. In an algebraic model, it's going to be in y equals mx plus b form. Okay, this is gonna be our line of best fit to match this. Okay, if you look, we have a table. And so the T represents years after 1980. So year 0 would be 1980. 5 would be 1985. 10 would be 1990. Okay, 20 would be 2000. 40 would be 2020. Okay, and so what we're going to do is basically we're going to create and figure out a model so we can figure out however many years after 1980, what would the population be. And so we need to figure out, so these are increasing by 5 years. We need to figure out, well, what is the increase per 1 year? And so basically we need to find our slope. And so again, from, we just did one, y2 minus y1 over x2 minus x1. Okay, this is not going to be exact. Answers may vary just because this is not a super duper exact constant. It's just a rough constant because it's, line of best fit. It's a prediction. And so because of that, I'm going to take the first and the last 2 points. I don't know. I like to do that in order to, have the biggest range. So the last one we're given and the first one we're given. So y2 over y1. And so our T represents x, and then our females represents the y. And so our change in y's would be 7.10 minus 3.9 over our change in x's, so our years, 25 minus 0. So 7.1 minus 3.9 is 3.2 over 25 minus 0 is 25. Okay, and so we simplify 3.2 over 25. That would be 0.128. So basically that's saying that our population for each year is increasing by 0.128 for females in the prison system. Okay, so that would be like your N. So Y equals, well, no, not Y, because our Y represents females. So our females, the number of females, is equal to 0.128 times T, which is the time in years after 1980. And then we need to figure out plus our starting point. Well, our starting point was this 0 and then 3.9. So that'd be plus 3.9. So no matter what, so if I wanted to figure out what the percentage of females in prison is in 2020, I would plug in a 40 for T, and that would give us the percentage for population of women. Okay, and it would be a rough because, like I said, we have a line of best fit here. It's not an exact because it's not, the number of females in the prison system isn't constant. It's kind of an approximation, and you just look at your trends and figure out, okay, let's make a prediction of what it could be. Okay. Now let's talk about solving algebraic equations. So we have 6x cubed minus 11x squared minus 10x equals 0. Okay. Hopefully, we're going to be solving by factoring. Well, hopefully we know how to factor, and that's kind of come back to us. So we have 6x cubed minus 11x squared minus 10x equals 0. So we need to solve for x. So looking at this, we have a cubed. Okay, we talked about factoring whenever we have squareds. Well, so that kind of should be a clue, like maybe I should do something first. Well, if you notice, they all three have x's. So I'm going to factor out an x first. I'm factoring out an x from all three terms. So we have 6x squared minus 11x minus 10 is equal to 0. Okay, so there's one factor. Okay, this can be factored out too into our 2 parentheses. So what I'm going to do is I'm going to take this 6x squared, I'm going to come up here so I have more room, and I'm going to say 6x squared minus 11x minus 10. Okay, we're going to factor this. So if you recall, C goes on top, B goes on bottom. Okay, so we have to slide and divide. So we have x squared minus 11x. 6 times negative 10 is negative 60. So factors of 60 would be 1 and 60, 2 and 30, 3 and 20, 4 and 15, and then 5 and 12, 6 and 10. Okay, so what is 11 apart would be this 4 and 15. So that comes up, I didn't even write this part. So the negative 60 goes up here, and the negative 11 goes down here. So 4 and 15, and we need 15 to be negative. So we have x minus 4, and we have x minus 15. Okay, so we slid that 6. Now we have to divide the 6. So divide this by 6, divide this by 6. So none of those divide evenly. And so what we need to do is simplify the fractions. 4 over 6, so we have x minus 2 over 3. And then here, 15 over 6, both divide by 3, so we have x minus 5 over 2. Okay, so now we take our denominator and we put it in front of our x. Okay, actually, no, I'm gonna leave it like this because this is kind of a shortcut that kind of hit me as we were doing a lesson one day. So I'm gonna replace this here. So we have x, and then we have x minus 2/3, and we have x minus 5/2, and that equals 0. So I'm gonna plug each of these factors equal to 0. Okay, so x equals 0, well that's just x equals 0. So I'm gonna put all of the solutions here. So x equals 0, that's just 0. So there's one answer. And then x minus 2 over 3 equals 0. If we add 2 over 3 here, cancel, cancel, we get positive 2 over 3. So hopefully you see like this was a negative, now it's a positive. It's always opposite signs. This was a negative 5 over 2, now it's a positive 5 over 2. Okay, if you don't see that or if you want to double check, you can always add 5 over 2 to get your positive. Okay, and that is how you find algebraic by factoring. Okay, so that is that problem. Okay, let's simplify this, get this away. Okay, let's do another one. So now we have x squared is equal to 10 minus 4x. Let's do this one by quadratic formula, okay? And I'm going to do the decimal and find the exact. I think this was probably the biggest thing in P, this whole thing in P is figuring out what it's asking for as far as your answer, okay? And trying to find that. I could spend a whole day on that. Hopefully as we get through it, it'll become easier, but we're gonna find the exact in terms of radicals. So we aren't gonna do, anytime it says exact and keep it in terms of radicals, or the approximate would be to round to the nearest 2 decimals. Because then we're gonna find both. Okay, so if we have x squared is equal to 10 minus 4x, well we cannot solve this one because it doesn't say equals 0. So we need to get everything on one side. So our x squared is on this left side. I'm gonna keep it there because it's positive and I'd like my x squared to be positive. So I'm going to subtract 10 and I'm gonna add 4x. Okay, so this would be the same thing as x squared minus or plus 4x, that goes next, minus 10 is equal to 0, okay? So now we know A is 1, B is 4, and C is negative 10, okay? We can't factor this because there's no 2 factors of 10 that have the addition or subtraction of 4. So what we're gonna have to do is quadratic formula, which I love. I prefer this method. So we have x equals negative b, so negative 4 plus or minus the square root of 4 squared minus 4 times a, which is 1, times c, which is negative 10, okay? That entire thing is over 2 times a, which a is 1. Okay, so this right here we put into our calculator, or we do that by hand. So we have 4 squared, which is 16. And then negative 4 times 1 times negative 10 would be positive 40. So that would be 56. Okay, so we have negative 4 plus or minus the square root of 56 over 2 times 1 is 2. Okay, so we need to simplify the square root of 56. 56 is not a perfect square. And so what we need to do is we need to find the roots of 56. Okay, so I'm going to say, I know 7 and 8 goes into it. That's the first one that comes to my mind. 7 is prime, so I'm going to circle it. Okay, 8, we have 2 and 4. Okay, 2 is prime. 4 is a perfect square, so I'm actually going to stop here because the square root of 4 is 2 times 2. So the square root of 56 is the same thing as 2 times 4 times 7. Well, the square root of 4 is 2, so I'm going to pull that out. So this simplifies to be negative 4 plus or minus 2 square roots of what's left over is 2 times 7, which is 14, over, we have our 2 at the bottom. Okay, so now we can simplify this. Take this term divided by the 2, and then whatever out in front of the radical divided by 2. So negative 4 over 2 plus or minus 2 root 14 over 2. Okay, well negative 4 over 2 is negative 2 plus or minus 2 over 2 cancels, so we just have root 14. Okay, and that would be your answer. So that would be your exact answer. Because we have it in terms of radical, there's no decimals, we're not rounding. That is your 1000% simplified exact answer. Okay, if we wanted to find the approximate answer, we would do negative 2 plus root 14, and then negative 2 minus root 14. Okay, so, and I'm going to do that exactly right here. So, negative 2 plus square root of 14 is 1.74. And then if we have negative 2 minus the square root of 14, we have negative 5.74. Okay, and so like on our graph, which actually, I take that back, I have that, 1.74 and 5.74. I'm going to erase this part so we can see. If we put those into our graphing calculator, or Desmos in this case, it would give you those answers. So our zeros would be negative 5.74 is what we got. So that's your approximate answer, but this would be your exact. So this is exact. This would be approximate. Okay. So now let's talk about this exact equation algebraically. Okay, and so a hint for you guys to look at how it wants you to write your answer, if it's exact or approximate, or what, read the blue. So type an exact answer using radicals as needed. So that tells me we're not going to have a decimal. We're going to have this in terms of radicals. So we have b squared minus 11 is equal to 12 minus 10b squared. So we want to get numbers on one side and variables on one side. Everything we need to equal 0. So I'm going to take everything and take it to the left. So first I'm going to add 10b squared to here. So that's a 1, so that'd be 11b squared. And then if we subtract 12, that would be minus 23 equals 0. So if you notice here, those are canceled over there. We are missing our b term. So our a is 11, our b equals 0, and our c equals negative 23. Okay, so quadratic formula, we have x equals, I know it says b, but it's the same thing. So the square root of, nope, just kidding, negative b, which b is 0, so it's just 0 plus or minus the square root of 0 squared minus 4 times a, which is 11, times c, which is negative 23. That whole thing times 2 times a, which is 11. Okay, so I'm going to type this right here into my calculator. 0 squared is just 0, so I'm just going to type negative 4 times 11 times negative 23, and we get 10, 12. So 0 plus or minus the square root of 10, 12 over 2 times 11 is 22. Okay, so the square root of 10, 12 is not a perfect square. So we have 10, 12 Okay, I know 2 goes into that. I'm gonna see if 4 goes into it. Okay, and it does, there's 4, sorry, and then 253 times, okay? And that's actually as much as it goes. So the square root of 1012 is 4 times 253. Okay, square root of 4 is 2, so this would be 2 root 253. So that I'm going to replace here. So we have 0 plus or minus 2 square root of 253. All of that is over 22. Okay, well, we can clean this up. 0 just goes away. So, but we still have the plus or minus. And so the 2 over 22 can simplify to be 1 over 11. So this would be the plus or minus the square root of 253 over 11. Okay, and that right there is your answer, your exact answer. Okay, and that's it, guys. So you guys have 9 total questions. Let me know if you have any issues, if you have any questions, comments, concerns, let me know. Okay.